Hello everyone, welcome to Computer Science E1. This is Lecture 2, Hardware Continued. And it seems it's pretty fitting that we get to talk today a bit more about hardware because just this past week, Apple announced some new hardware that I want to show you a video about actually right now. So enjoy.
When a product comes along that appears so stupid that the ways that you can make fun of it are practically endless, it actually becomes magical. I mean, as comedy writers, the range of jokes that we can make about the iPad is as wide as the useless piece of itself.
The iPad's absurd and unwieldy size makes it nothing short of a revolution in parody inspiration. Do we call it the iPod Jumbo? Do we create a sketch using an iPhone calling it the iPad Nano, where we suggest that the smaller one can actually make phone calls? I mean, the options are limitless. I don't have to write jokes about the iPad. The iPad practically makes jokes about itself. It's incredible.
Now, the name iPad brings to mind feminine hygiene products. And this is something we're really excited about. Maxi pads, tampons, menstrual goods of all kinds. We could also make puns, like calling it the I Paid Too Much, or just saying that this is what people in Boston have been calling iPods for years. See, these jokes come so naturally, you don't even have to think about it. You just mock.
If you want to go with the idea that this thing makes Amazon CEO Jeff Bezos try to commit suicide, you can. If you want to pull a 180 and say, sure, I love reading books on a bright LED screen that hurts my eyes because I hate myself, you can do that too. It's two completely opposite approaches that are both valid. It's just a pleasure.
It is the most obviously useless piece of technology we've seen around here in a long time, maybe ever, but certainly in my time here at College Humor. The ultimate uses, they just come to you as if in a dream, there's a saucer, dinner plate, frying pan, frisbee. I mean, it's endless. I truly believe we're entering a new comedy gold rush.
Now, we decided on the meta approach because, we've learned so much from our other parodies of Apple products that we really felt that we could take a whole new, revolutionary, magical, phantasmagorical-icious, expialidocious approach to this big, easy target. I mean, it's almost like the iPad has a big kick-me sign on its back. Quite simply, this little retard TV is going to change the way that we make fun of Apple.
Now this is pretty funny because if you actually go to Apple's website and you actually go to Apple's website, they have this really long intro video about this device that they just released, and they're always using all these extreme adjectives to describe it. Magical, wondrous, awesome, really great, all of these sorts of things. And after a while, it looks kind of neat, but after a while you realize that there's also a lot of hype behind it as well. And it's pretty interesting, I think, that they released this because it's one of these things that it's sort of a technology that we haven't really seen before. Maybe it's a logical evolution rather than a revolution in technology in terms of what we currently have available today, because many people are comparing it to basically just an oversized iPhone, and maybe that's all it will amount to. It remains to be seen. But in the end, this is still basically a computer at heart. And so it is what it is, and it's small, it's relatively thin, but it can do things now in 2010 that we frankly were just not able to comprehend even just a few years ago. It just seems so futuristic and so far off in terms of what it was able to do. And at the fundamental level, this still does the same sorts of things that we were talking about last week. In order for it to do its computation, it has a CPU inside of it, and this CPU calculates and does stuff based on the binary language of zeros and ones.
So you're going to get one?
I tried as long as I could to not get the iPhone. I did everything. I was like, oh, this iPhone's a piece of junk. I'm never going to get it. And then I caved months later. So I'll just say, yeah, probably.
Yeah, so don't think we're being too harsh on this because, in fact, people tend to be very harsh on Apple anytime they release something new these days. Expectations are sort of over here. And frankly, I don't know what people were expecting that they're now so blatantly disappointed with this. But I was fascinated and also reassured in terms of my stock portfolio when a friend of mine actually forwarded me this link. Do you mind toggling over for a second? The date of this bulletin board is October 23rd, 2001. And if you thought people have been a bit harsh on the iPad now, I thought I would read some excerpts from when the iPod itself first came out. So This is perhaps choice. I poop, I cry, I was hoping for something more. Great, just what the world needs, another freaking MP3 player. Let's scroll down here to, I still can't believe this. All this hype for something so ridiculous. Who cares about an MP3 player? I want something new. I want them to think differently. Why, oh why would they do this? It's so wrong. It's so stupid. So frankly, I dare say we heard, 9 years ago, the same kind of rhetoric people are blathering on the interwebs now. So it'll be interesting, needless to say, in a few months to see just what this and the future brings. So.
That's right. So last week we were talking a bit about binary and how we were able to represent also characters with this binary representation, or with zeros and ones. And we actually have a small demo that we wanted to show last week but couldn't, and so we're going to try to do it now.
So we need 8 volunteers, believe it or not, for this. So this is your moment of awkwardness at the start of the semester. Do we have 8 people brave enough to, 1, stand here? You don't have to say anything. You just have to stand here a bit awkwardly, but you do have to be comfortable appearing on camera. So that's the 1 gotcha. Yeah, 2, come on down. 6 more. 3, 4, 5, 6, 7. 1 more. 8, come on down. All right. So, as a little quiz first, the goal is for each of you to stand in front of your classmates here holding a piece of paper. I'm going to give each of you 1 piece of paper. Keep the big, bold number in front of you, facing your classmates, and I will leave it to you to sort yourselves. So, a little bit of a quiz here for you all, and then we'll challenge the audience here. So, please arrange yourselves as you should. We'll fix it in a sec. All right, and finally... So you'll recall that one of the topics last week, okay, ready, arrange. One of the topics last week was, if you're not sure what you're doing, look to the person to the left or the right, perhaps. One of the topics last week was the whole binary system. Binary meaning bi, for 2. So the language that computers actually speak. Oma? Perfect. Yeah, yep. Excellent. So good. Excellent. So this is a bit of a recap of a byte, a bit. So each of these humans, each of these classmates represents a placeholder. We have the 1's place down here, the 128's place over here. And recall that using 8 bits, can you express not just numbers, but also alphabetical letters? Using what code, what scheme? Yeah, ASCII, A-S-C-I-I, which was just a mapping from letters to numbers, numbers to letters. And even if you don't remember almost all of them, what was one key value that's easy to remember? 65 was the letter A, and we can pretty much reverse engineer everything from there. So we've gone ahead and prefabbed a little bit of a riddle for you all, a 3-letter word that these folks are going to spell out. On the backs of their sheets of paper are 3 steps. 1, 2, 3. They're going to do each of these steps in turn, and what I'm going to ask you 8 to do is, if you are told to represent a 1, just put a hand up to make it clear that you're a 1, and if you're a 0, just stand there awkwardly. All right, so ready? Round 1.
Here, try lifting up your papers. How about doing that? That'll make it more obvious. Yeah. There you go.
Oh, now we got...
Well, no, okay.
Okay,
Never mind.
so what do we have? We have someone... What number is being represented at the moment? Audience, please. We have A64, but a somewhat shy gentleman over in the 2's place. So 66. Okay, so the number 66 is currently encoded by this byte, which means they are representing the letter... B. All right, so you were a capital B. All right, hands down. Excellent. Round 2 of 3. Go. Can someone second that? 79. We got a 64 over here. An 8, so that's 72 plus 4 plus ... 79. Yay, nay? Okay, 79. So what are they representing? O, so we have B-O in the big finale. Bring it home. Round 3, if you would. Don't shout out just yet. Give a few people a chance to do the math. And what do you got? I see some murmurs of 87, in which case they are representing the letter W, which means they've just spelled bow. So if you would take your bow, congratulations. Thank you very much. A round of applause for our volunteers here. And if you don't mind, The internet and the lawyers require that we just get your signature on these pieces of paper. So consider this a nice little parting gift. You can bring it back to your chairs. We'll get it during the break. So to summarize, last week we looked at the very basic building blocks of computing, which ultimately reduces to either some electricity, storing ones and zeros as electronic signals flowing or not flowing, or even magnetic particles on things like hard drives and floppies, doing the same, albeit in a different manner. So that was week 1.
So you might remember that we have this device in a computer, and it's sort of the main brain, so to speak, of this computer. And it actually is what does the computing. What is this device that we have? I know you know the answer. This is not a hard question. Not a trick question, I promise. Okay, I'll say it myself, the CPU. So we have the CPU sort of in the center of the computer, and its main goal, and this is just a reminder of some of the material that we went over last week, is to be able to process this information. So we might get some input. So we have a variety of what are called input and output devices, and you'll hear this term sometimes. Input and output is used collectively sometimes in a term known as I/O. I/O is just really an abbreviation for this term input-output. So we can sometimes input information into the computer by a variety of means, like the keyboard, for example, or the mouse, or maybe some other device like a scanner or digital camera, any method that we can actually input information into the computer. Then usually the computer has to do something with it, which is where it goes to this data goes to the CPU. Whatever is being done to this data is being processed in it, and then it is output to us through a variety of means as well. So you might be able to guess what are some various output devices that we might have. So this is now something that would be where the computer would show information to us. So not software, because that's usually what helps use the CPU to process this input and provide this output. But there's these devices, just like we have a physical keyboard and we have a physical mouse, that are used as interfaces to allow us to input data. There's also interfaces that allow computers to display data to us. So yeah, so like a monitor, a screen, a printer, sound, so like speakers and sound systems, etc. All of these are known as output devices. And this becomes especially useful when we start talking about peripherals. But in the meantime, that's just a big tease to some of the stuff that we have coming up a little bit later. But in the meantime, it's a little bit more complex of a picture than this for the computer to do its processing. As you might recall, we store the majority of our data where? So when the computer is off, it's stored somewhere in the computer. Hard drive? Right, on the hard drive. So we have something that we abbreviate as HDD, just to represent hard disk drive. This is what stores the majority of your data, your programs, your photos, your music, all of the things that you actually use on your computer are stored in the hard drive. Now, we also talked about how this is a type of memory. This is what's called a non-volatile memory. In other words, it's memory that is not going to get lost. The data is not going to get lost as soon as the power is cut. But there's another type of memory that we have as well, where all of this data is loaded from the hard drive into this type of memory, and that is what is actually used, that the CPU actually uses to reference. So what was this third type of block that we have? Right, RAM.
You may recall this picture was backwards last week since I'm right-handed and Dan is left-handed.
I'm left-handed, yeah, so this is the correct way to think about it for the 10% of you that are left-handed. Anyway, so we have this, and if you're right-handed, it's mirrored, but it's basically the same thing. And we said that we have this idea of hard drives having a lot of data or a lot of capacity, RAM having nowadays quite a bit, but not anywhere near as much as modern hard drives. And these caches, or even smaller pieces of memory between the RAM and the CPU. So just this sort of funneling of data before it actually gets to the CPU. And what was the purpose of this? Why did we have this sort of pathway? Why don't we just skip all these middlemen and just have the hard drive and the CPU? What's the problem? Right, so the big problem is that we want to be able to quickly get from memory a lot of the data that we are currently using. So sure, you might be able to store a whole bunch of stuff on your hard drive, but you're not going to be using it all at once. You're not going to be playing all of the music files at the same time from your hard drive, for example. You're not going to be viewing all of the photos that are on your hard drive at the same time or using all of the programs. So it seems logical to have this less expensive but slower memory that is a permanent storage where we can store all of our stuff even though it might temporarily not be used. So we load only